Two racing cars A and B are at rest alongside each other at point O on a straight horizontal test track. The mass of A is 1200 kilograms. The engine of A produces a constant driving force of 4,500 newtons. When A arrives at P, its speed is 25 meters per second. Distance OP is D. The work done against resistant force experienced by A between O and P is 75,000 joules. Show that D is 100. I want to start by looking at some equations and when we can use them. Okay, the first equation we all know is work done equals force times distance. Work done is FD. Now that's quite easy to understand, because if you exert the amount of distance you exert, a force is proportional to the work done. So if you're pushing a car at 200 newtons, okay, the longer the distance you do that for, the more work done. So it makes sense that as you increase the distance, you increase the work done. Okay, now this is specific to a certain force. Okay, for example, the engine, it could be the work done by the engine equals the driving force of the engine times the distance that the vehicle moved for. Or it could be work done against resistance equals the frictional resistance times distance the object was moved. So these two correspond. This is not the total work done. It doesn't have to be that. It doesn't have to be. It's specific to the object. Okay. So we got two things. We got work done by the engine, and we got work done against resistant force. Well, the work done by the engine is contributing to a build-up of speed, and the work done against resistance is hindering the speed. Okay, while we're talking about this equation, we could also talk about the rate of work done. Okay, so if we wanted the rate of work done, it's work done per second. So I divide that by time. So if I did that, I need to divide this by time. Well, this is really work done is energy. So energy per second, or energy divided by time, is power. So the rate of work done is the power. Okay, equals F times, well, distance over time is speed or velocity. So that's where this equation comes from. So really, the P equals FV is really very easily derived from the work done equation. Okay, well, we're not interested in power in this particular question, so let's delete that. Well, can we not use this equation then to solve D? Okay, there's our D. Okay, if we talk about the work done by the engine, do we know the work done by the engine? We don't, but we know the driving force of the engine. That the engine produces a constant driving force of 4,500 newtons. Okay, so we've got F. We want to work out D. We just need the work done by the engine. Okay, this is work done by engine equals driving force of engine times the distance moved. So we need to work out the work done by the engine. And then once we've got that, we can use this equation to work out D. Okay, let's go back to the question. Okay, so at O, it's motionless, and then the racing car A is travelling at a velocity of 25 meters per second. So it's gained kinetic energy. So it's got kinetic energy here, it's got zero kinetic energy here. Now, where has this kinetic energy come from, this build-up of kinetic energy? Well, yeah, it's come from the engine. It's come from the work done by the engine. Okay, and well, let's see what kinetic energy it's got. We can calculate that. Okay, so kinetic energy is half mv squared. It's half times the mass, which is 1200, times 25 squared. Okay, and that comes to 375,000 joules. Okay, so it's accumulated 375,000 joules of kinetic energy. There is no potential energy because it's flat. Okay, so it goes from here, it's got 0 joules of kinetic energy, 0 joules to 375,000 joules. Now that energy has come from the engine. Okay, so we can make an equation here. We've got the work done by the engine. Now, does the work done by the engine, is that going to equal 375,000 joules? No, because of the resistance. Okay, so the work done against the resistance is 75,000 joules. So this is hindering the speed. So the greater this is, the lower the speed is going to be. Okay, so therefore it's a hindering force, so it's a negative force. So work done by the engine minus work done, against means minus. So work done against resistance equals the kinetic energy. Okay, so work done against resistance is 75,000. So we got an equation. Work done by the engine, subtract 75,000 equals the kinetic energy of 37500. So take this to the other side. Okay, so we end up with work done by the engine is 450,000 joules. So now we have work done by the engine, and we got the driving force of the engine. We can use work done is force times distance to work out the distance. Okay, work done is force times distance. So 450,000 equals 4500d. So we work out d is going to be 450,000 divided by 4,500, which is 100 meters. Okay, we've shown that d is 100. Okay, this is the same sort of thing, but the other way around. This time they're asking for the mass of the car. Okay, so we can't work out the kinetic energy of the car because we don't know the mass, but they do tell us. They tell you more. You've got the driving force of the car and the resistance of motion. Okay, first of all, let's think about the kinetic energy. Let's work out what the kinetic energy is in terms of m. So, kinetic energy will be half mv squared. It's half m 25 squared, which will be 312.5 m. So we got our kinetic energy of car B. It's very similar. It starts with 0 kinetic energy and ends up with 312.5 m kinetic energy. And that kinetic energy comes from the engine, comes from the driving force of the engine is producing that. But the resistance to motion is hindering it. So the work done, not the driving force, the work done by the engine minus the work done by the resistance equals 312.5 m. Well, we can work out the work done by the driving force because we've got the driving force and we've got the distance. Work done is force times 100. And then the work done against resistance is force, 1200, times distance. Okay, so we can complete the equation. So work done by engine is force 3200 times the distance, which we calculated as 100. Okay, so the work done by the engine is 32000 joules. Work done against friction is the force, which is 1200, times the distance, which we know is 100. So that's 12,000 joules. Okay, I just made an adjustment here. Okay, so this kinetic energy of 312.5 M comes from the work done by the engine, 320,000, but it's hindered by the work done against friction, 12,000. So we can say that 320,000 minus 12,000 equals 312.5 M, and calculate M. So work done by engine minus work done against friction equals kinetic energy. $200,000 equals 312.5 M. So M equals 640 kg. Okay, find the steady speed which B can maintain when its engine is working at the same rate as P. What does this mean? Engine working at the same rate. Well, the rate of working is power, because its working is energy, so and the rate is per time, per hour. So work rate is power. So firstly, we need to know what this power is. Okay, so we need to know what power it's working at P. That's a simple calculation. We know the driving force of the engine B, it's 3200, and we know the velocity is 25. Okay, so that comes to 80,000 watts, 3200 times 25. So the engine is working at a power of 80,000 watts. So when it's working at a power of 80,000 watts, what's the maximum speed it can maintain? Okay, when it says can, possible. So at 80,000 watts, what is the highest possible speed it can maintain? So it's absolute maximum, and it will just stay at that maximum, because unless it exerts more power. It could be that this is the maximum power. So if the maximum power is 80,000 watts, what's the maximum speed? Okay, so there's our car B, okay, and it's travelling in this direction at our constant value of V. This is our maximum velocity. Okay, and we have our resistive force of 1200. Now this bit is more difficult to understand. If we go back to our power equation, P equals FV, if we make F the subject, F is P over V. Okay, so you can see if we keep the power constant at 80,000 watts, the driving force is dependent on the velocity. So as the velocity creeps up, the driving force is less. I mean, that makes sense, because if you're driving along at high speed, let's say 100 kilometers an hour, you can't accelerate as quickly as if you're driving along at 20, and you come to a point where you cannot accelerate anymore because you're at maximum speed. Okay, so the driving force is P over V. So